Hi, hello everyone. My name is Putri Kalila. In this video, I'm going to present a progress of my data science project during trimester 1 and trimester 2. As from the title of the slide, we are going to unravel the mystery of socks knitting difficulty. Before that, this presentation will be divided into two portions. The first portion will be a group work effort, while the second portion will be my individual work effort. Without any delay, let's begin. So in this project, we are interested to study a socks knitting difficulty rating average. So where is this socks dataset coming from? The socks dataset is created by our supervisor, Dr. Lauren Kennedy. So she scraped this dataset from Ravelry website. Ravelry website is a very prominent marketplace website for fiber arts, including knitting and crochet. On this website, people can share, can sell, or even discuss about their socks knitting pattern. Not just socks, can be anything, but it's all about knitting and crochet. So a little bit about this project. The driving motion behind this is to understand which features in the knitting socks dataset give impact to difficulty rating average. We are meant to develop a predictive model to assess the socks pattern difficulty rating average. Why difficulty rating average? Why is this so important? This target variable is very important because it will help not just for the beginner, but for everyone as a knitter or as a crochet that love to crochet to understand, is this pattern, is this easy, is it hard, so they can anticipate and ensure their enjoyable knitting experience. So throughout this presentation, I will present the challenges that we had faced in terms of missing data, conversion of data types, and feature selection. In the end, the mission of this project is to clean as much as possible and to pre-process the dataset to make to improve its predictive capacity. So what exactly inside the socks knitting dataset? So this socks dataset have 51 columns with 5,000 rows. In that dataset, we have like different data types such as characters, lists, logical, and numeric. Each socks in the dataset provide details on how to make the pattern. For example, from the picture here, we can know when is it published, the suggested yarn, the yarn weight, the gauge, the needle size. All of this is a features of the socks pattern itself. Notice in this about this pattern box, so there's an average difficulty. Next, I will explain how do we calculate difficulty rating average. Since we are interested how the features affecting the difficulty rating average, we have to know how is it being calculated. So over here, I have the example of strawberry martini socks pattern. In the data set, the strawberry martini have a difficulty rating average of 5.072. But how did you get this value? So notice over here when I clicked about this pattern and this 306 rate, this for example, but click the rating, the link over here, it will open this statistic of that ratings of the socks itself. Focus on these difficulty ratings down here. So how do we, in the data set, we have a two important column, which is difficulty rating average and a difficulty count. So difficulty count is the people who rate that socks pattern. So for example here, for strawberry martini, we have 110 counts because it's coming from, notice over here, there's 11 user, 12 user, 20 user. So how did this 5.72 got this value is because it's multiplying with the number of user had rated with the number of each rating level. For example, rating level 1 have a 0 user because there's no one rated as 1 for this pattern. But for rating level 2, there's 11 user that rated 11 for this socks pattern. So this number is multiplied with each other. 1 times 0, 2 times 11, 3 times 12, and it will be totaled up to 558 divided by 110, which is the number of users that rate the pattern. Hence, the value is 5.072. I hope it's clear how do we calculate the difficulty rating average. So what is the challenge with the data and how do we solve it? So during the exploratory data analysis process, we managed to identify the columns with the missing data, and also we need to need some conversion within the data set itself. So before we understand which column have a missing data, we need to understand the missing mechanism itself. Cited by Rubin 1976, it mentioned they have three types of missing mechanism. First, missing completely at random, missing at random, and missing not at random. The one that we want to avoid is the last one, which is the missing not at random, because this will be a worst case scenario, because where this missing data depends on its own value or unobservable variables. So it's very hard, to impute it based on other observable data, which is other columns. So during the EDA process, we notice that difficulty average have also missing value, and difficulty count has also missing value. If difficulty count is missing, it means that the pattern has not been rated yet. And then this is normal in this Ravelry website situation, because if the data is fairly new, nobody has tried to knit it, so there's no rate on that pattern itself. If difficulty rating is missing but difficulty count is present, we can use imputation to fill in this missing data. Next, we notice as a price value column may be empty because this indicate a free pattern. So in this Ravelry website, owner of the pattern can either sell it or can either share it for free. So if the price column is empty, or zero means it's free, or empty means it's free as well. So we need to make sure that this missing value data type being captured or being converted appropriately. Next, we also found columns with a missing value such as row gauge, yardage, and yardage max that may have a missing values due to oversight by the pattern owner. Probably the owner of this pattern forgot to fill in the length of the row gauge, the length of the yardage, and so on. So how do we solve the missing value situation? We are using MICE method, which is multiple imputation by chain equation. So how exactly MICE work? MICE is an iterative imputation method that impute missing value in a dataset by modeling each variable with missing data as a function of other variables. It might sound complicated, but here's the easiest version. For instance, let's say we have three variables, A, B, and C. If A has a missing value, we use the observed value from B and C to estimate the missing value of A. Then we move on to B, using the observed value of A and C, and so on. This process creates a chain equation where each variable missing value are estimated based on each other. Notice from this picture over here, the first one is you have an A value, and the second picture have a value of, for example, the first row, we have a value 1084 over here, and then the row gauge become 8. So this is how the mice work. For example, right? It will use a column or a rows with a complete data, and then based on that observed data, it will impute the data on the missing value itself. Next, in the data conversion, we notice in the price column, it came from a various country. For example, over here we can see price of 3.5 GBP, which is coming from UK, and then 4.5 USD, which is coming from USA. This price column need to be normalized to ensure uniformity value. If we fail to normalize, this could lead to inaccuracy in a price prediction. So what we did is that we find the conversion value for each country based on each value over time, because the value of money fluctuates over time, so it requires adjustment. We use Australian dollar to normalize all their conversion into one one type of conversion rate. All right, after the imputation process, notice pictures on the right. For the row gauge, gauge divisor, yardage, and other features column has been imputed is within the original data range. So notice here for the row gauge, we lay over the imputed data and then the original data. All of these pictures is shows that the imputed data is within the original data range. So this is indicating that using mice is suffice enough to impute this missing data. And then we fit our imputed data set with using linear regression models, and it gives us an R squared of 0.16, which is 16%. It shows that 16% of this variance in the predicting difficulty average can be explained by our models. So right now we will jump into our second portion, which is my initial effort on how to understand this data set more. So my research question is that I wanted to see, do COVID-19 event affecting the difficulty rating average over time? So if you notice over here, my initial assumption is that there will be a sharp increase in the difficulty rating average, because if you look at this picture, right, after 2020, the red dotted line shows is indicating the COVID lockdown, which is March 2020. So after 2020, we can notice over here there's a spike of numbers of rating or number of patterns has been released after 2020. So I really want to explore this path. Is it really a COVID-19 affecting difficulty rating average? So using the price column, I use it as a location proxy, because to understand about COVID, we need a geographic location. So in our data set, the only nearest column that I can understand about location is the price, because in the price column, we do have a different currency. I noticed that um, there is no sudden spike or no trend in this difficulty rating average. It is fluctuating, more noise for all of this country. And one more thing for me is difficult to see if there is a significant spike or not, because different country have a different lockdown date. I still lay off the difficulty rating over times over here if you see the first graph. And then I notice is more noise. It's not clean. So hence what I did is that I tried to aggregate all these data point by month. So you can look down here. This is the average difficulty of SOX pattern over time. So notice there is a trend. There's a trend definitely happening in here, which is after 2015. There's an increasing trend in our difficulty rating average. So what is moving average and how did it work? Moving average calculate the average of a subset of the data points within a given window. So the purpose of using moving average is to smooth the data, because notice my original data is very fluctuating, right? So using the moving average, it can help to smooth the plotting the data points. And using moving average can forecast my future difficulty rating average as well. So for this picture, you notice that in the beginning and then the ending is like an empty line. This is because I'm using a 12-month window, meaning that, for example, if I wanted to calculate um uh, January 2008, I need a 12 months previous, meaning that from January 2007 until December 2007, then it will get my first point of January 2008. Same goes for February 2008. I need a 12 months window time, which is it will calculate from February 2007 until January 2008, and so on. And that's how the moving average work. Then I'll forecast my moving average. So using here, notice over here, I forecast for the next 12 months, meaning since our data is until December 2023, I'll try to forecast the next 12 months. It's very nice using this forecast moving average function, because Instead of giving us a specific value of prediction points, it gives us a confidence interval. So in this gray dark area is a lower and high 80% confidence interval, while the lighter gray out here is giving us the lower and upper 95% confidence interval. All right, that's all about my progress. Thank you for watching. Bye.